Good morning, students. So in the last class I started the chapter moving charges, that is magnetic effects of current and magnetism. So in that chapter you are having two sub chapters. The first chapter is moving charges and the second chapter is magnetism and matter. So in moving charges I try to make you understand about magnetic field and magnetic force. Here see, magnetic field, it means if a wire is carrying the current, if in a wire electric current is flowing, means then around the wire there will be a force and a field. That force attracts the different metals and repels the different metals. So we can call that force as magnetic force and that field as magnetic field. Thus the space around a current carrying conductor where a magnetic needle or a compass needle shows deflection or experiences a force is called a magnetic field. And magnetic force is the force present between two electrically charged particles. Magnetic force is Fm and magnetic field is capital B. Symbol for magnetic field is B. Symbol for magnetic force is Fm, capital F to the base M. So now I am here to tell you about one new concept, that is Laurent force. Imagine a positive charge, say Q coulomb. A positive charge is moving in a region of crossed fields. Crossed fields means it is the combination of two fields. If a charge is moving in a region of electric field and magnetic field, the combination of these two fields is called crossed field. ಎರಡು ಫೀಲ್ಡ್ ಇರುವಂಥ ಜಾಗದಲ್ಲಿ ಒಂದು ಚಾರ್ಜ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ಅಂದ್ಕೊಡ್ರಿ. ಎರಡು ಫೀಲ್ಡ್ ಯಾವ್ಯಾವು? ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡು, ಇನ್ನೊಂದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಮತ್ತು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಎರಡೂ ಫೀಲ್ಡ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇರುವಂಥ ಒಂದು ಪ್ಲೇಸ್ನಲ್ಲಿ ಒಂದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಮೂಮೆಂಟ್ ಆಗ್ತಾ ಇದ್ದರೆ, so that positive charge now it experiences two kind of forces on it. One force is one force is electric force and the second force is magnetic force. So here the two forces are acting on the charged particle. So for the first time a scientist named Lorentz, he explained about this force. He explained about a concept where the particle, a charged particle, experiences two kind of forces, which are electric force and magnetic force. So therefore that force is called on the name of the scientist, therefore it is called Lorentz force. Yes, what is Lorentz force? Lorentz force is the force acting on a charged particle entering into a region of both electric field and magnetic field. Yes, how to define the term Lorentz force? Lorentz force is the force that acts on a charged particle which enters into the region of electric field and magnetic field. So here the Lorentz force is given as F vector. Force is a vector quantity. F equals to, here electric force means QE. Formula for electric force is QE. Q is electric charge, E is electric field. Plus magnetic force is Q into V cross B. Expression for magnetic force is Q into V cross B, where Q is electric charge, V is velocity or speed of the charged particle and B is the magnetic field. So see here Lorentz force is given by the formula F equals to QE plus Q into V cross B. So Q is the common factor here, therefore F equals to Q into E plus Q. I am taking Q outside, Q into E plus V cross B, right? So yes, what is the formula for Laurent force? F equals to Q into E plus V cross B. Here you can clearly see that V cross B, vector V cross vector B, it is the vector product or cross product. Here there is a cross product in the Lorentz formula. So what it means? This force exists. This force, see, this force acts on the particle if the particle moves only perpendicular to the magnetic field surface. If the particle is moving, see, V cross B, V is velocity, B is magnetic field. So if V is V cross B na ಏನಂತ ಬರಿತೀವಿ ನಾವು? V cross B equals to VB sin theta n cap ಅಂತ ಬರಿತೀವಿ ನಾವು. A cross B, vector A cross vector B, AB sin theta, ವೆಕ್ಟಾರ್ ಪ್ರಾಡಕ್ಟ್ ಲಾಸ್ಟ್ ಇಯರ್. ಇಲ್ಲಿ ವಿ ಕ್ರಾಸ್ ಬಿ ಅಂದರೆ ವಿ ಬಿ ಸೈನ್ ತೀಟಾ ಅಂತ ಬರ್ತದೆ. ವಿ ಬಿ ಸೈನ್ ತೀಟಾ ಅಂತ ಬರೆದ್ರೆ ಸೈನ್ ತೀಟಾದಲ್ಲಿ 90 ಡಿಗ್ರಿ, ಸೈನ್ 90 ಈಕ್ವಲ್ಸ್ ಟು 1, ಸೈನ್ 0 ಡಿಗ್ರಿ ಈಕ್ವಲ್ಸ್ ಟು 0, ಸೈನ್ 180 ಡಿಗ್ರಿ ಈಕ್ವಲ್ಸ್ ಟು 0. ಸೊ ಈ ಪಾರ್ಟಿಕಲ್, ಇಫ್ ದ ಪಾರ್ಟಿಕಲ್ ಮೂವ್ಸ್ ಪ್ಯಾರಲಲ್ ಆರ್ ಆಂಟಿ ಪ್ಯಾರಲಲ್ ಟು ದ ಗಿವನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್, then its force is 0. Force acting, Lorentz force becomes 0. Because when the particle moves parallel, angle between V and B is theta equals to 0 degree. V cross B, VB sin theta, sin 0 degree equals to 0. When the particle moves anti-parallel to the surface, angle is 180 degree. So sin 180 is 0. So here the concept is Lorentz force acts on the particle only when the particle moves at right angles to the given magnetic field. This is the first point. Lorentz force becomes 0. Lorentz force is 0 if angle is 90 degree. 0 degree parallel agodre 0 degree or anti-parallel ಅಂದ್ರೆ 180. So force is 0. So here the particle must move at right angles to the given magnetic field. Next thing, here the formula involves F equals to Q into E plus V cross B. So Lorentz force dependent on charge of the particle, velocity of the particle, magnetic field of the particle, electric field of the particle. It depends on Q, E, V, B, right, as the formula is showing. So here if charge is equal to 0, if the charge equal to 0, then there is no force. If V equal to 0, ಚಾರ್ಜ್ 0 ಇದ್ರೂ ಫೋರ್ಸ್ ಇರಲ್ಲ. ಅಂದರೆ ಚಾರ್ಜ್ಡ್ ಪಾರ್ಟಿಕಲ್ ಏನಿರುತ್ತೋ ಅದ್ರ ಮೇಲೆ ಮಾತ್ರ ಇಲ್ಲಿ ಫೋರ್ಸ್ ಡಿಪೆಂಡೆಂಟ್ ಇರುತ್ತೆ. ಇಟ್ ಈಸ್ ಪಾಸಿಟಿವ್ ಫಾರ್ ಪಾಸಿಟಿವ್ ಪಾರ್ಟಿಕಲ್, ಫೋರ್ಸ್ ಈಸ್ ಪಾಸಿಟಿವ್ ಫಾರ್ ಪಾಸಿಟಿವ್ ಪಾರ್ಟಿಕಲ್, ಫೋರ್ಸ್ ಈಸ್ ನೆಗೆಟಿವ್ ಫಾರ್ ನೆಗೆಟಿವ್ ಪಾರ್ಟಿಕಲ್, ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಡಿಪೆಂಡೆಂಟ್ ಆನ್ ಕ್ಯೂ, ರೈಟ್? ಇಫ್ ಕ್ಯೂ ಈಕ್ವಲ್ಸ್ ಟು 0, ದೆರ್ ಈಸ್ ನೋ ಫೋರ್ಸ್. ಇಫ್ ವಿ ಈಕ್ವಲ್ಸ್ ಟು 0 ಅಂದರೆ ಚಾರ್ಜ್ ಇದೆ, ಪಾರ್ಟಿಕಲ್ ಮೂಮೆಂಟ್ ಆಗ್ತಾ ಇಲ್ಲ ಅಂದರೆ ಫೋರ್ಸ್ 0. So there is no magnetic force acts on the, there is no Lorentz force acts on the particle, only electric force will be present. If V becomes 0, you have F equals to QE. So in the absence of the speed, if the particle is not at all moving means, then the particle will have only electric force, that is F equals to QE. Magnetic force is 0. So you try to understand, only a moving charged particle, only a moving charge can give rise to magnetic force. So here magnetic field, magnetic force, they exist only in the presence of a moving charge. So what is the source of magnetic field? Moving electric charge. Moving electric charge is the basic source of magnetic field and magnetic force, right?